Hello guys, this is Dr. Possibility from Excel Academy. Kindly make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. In this tutorial, I'm just going to do my mathematics exam preparation part 5. So please make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. So let's quickly look at some few exam questions from different topics. So the first question is solve the equation for x, whereby the first one we have been given 3 to the power 2x plus 1 plus 5 is equal to 16 3x. So let me quickly write my solution. So I'm going to say solution. So in this case, we have been given that expression. So I'm just going to rewrite it, which is 3 to the power 2x plus 1 and then plus 5 is equal to 16, and then we have 3 to the power x in brackets. So with this being done, we can just simply rewrite this expression. We can simply write this expression. Since there is that addition, that simply means that this can be written as 3 to the power 2x dot, remember I'm using dot to represent multiplication, 3 to the power 1, and then plus c 5, and should be equal to 16, and then 3 to the power x cross brackets. So after you do that, you can simply rewrite this expression. As you can see, we have a 3 to the power x in those brackets, so we can make this to be related to that. So in such a case, we can simply say 3 to the power x, and then we say bracket, and then this 2 can be outside there, and then we can say dot, and we know 3 to the power 1, it's just simply 3. Then we can say plus 5, and this should be equal to 16, and then open bracket 3 to the power x, like that. So if you look at this, you need to understand that there is no other way we can solve this expression apart from us looking for any variable and we make it to be equal to 3 to the power x. So we can say let p be equal to 3 to the power x. Then, so since we have made p to be equal to 3 to the power x, that simply means that where there is 3 to the power x, we can just simply put p. So in such a case, we are going to have p to the power 2. Remember, we have put p there where there is 3 to the power x dot 3, and then we say plus 5, and this should be equal to 16p. Remember, this 3 to the power x will be replaced by p. So after you do that, your next step should be solving this guy. So you can simply say p squared times 3, which is just 3p squared. So this will be 3p squared, and then this one can go to the other side, so it's going to be 16p. It's going to be 16p, and then that 5 will still be the 5 the way it is, so plus 5, and it should be equal to what? Should be equal to 0. So with this in mind, ladies and gentlemen, we can try out product sum factor for us to factorize that. So we can say product sum factor. Okay, we can use this method, or you can use that quadratic equation, or you can even use the complete the square method. But when it comes to the exam, you need to make sure that you are fast and you're able to finish fast. So for the product, you say 3 times 5, which is simply 15, and then you say the sum is negative 16, of which the product will simply be equal to what? Will simply be equal to 1 and 15, of which both of them are supposed to be what? Negative. Okay. So after we do that, we can simply rewrite this expression to be 3p squared. Then you can say minus p, and then you can say minus 15p, and then you can say plus 5 is simply equal to 0. With that in mind, we can factorize by grouping. So let's quickly factorize. So if we factorize a p there, we're going to have 3p minus 1, 3p minus 1, like that. And then here, for us to make sure that this guy is the same as the other part, so we can factorize -5. So you factorize -5, and -5 into negative 15p, it is just 3p. And then 5 divided by -5, it's -1. And then this should be equal to what? This should be equal to 0. After you do that, you can group this one and that one. So this one will be p minus 5, and then the other one will simply be equal to 3p minus 1, and then that will be equal to what? Will be equal to 0. So when you do that, your next step is very simple. What you are going to do, you are going to take p minus 5, you equate it to 0. P minus 5, you equate it to 0, and then you say O, you say 3p minus 1 is simply equal to 0. So after you do that, you can take 5 to the other side. So p will simply be equal to 5. In this case, p is 5, and then there 3p is equal to 1. 3p is equal to 1. Then you divide throughout by 3. Then you're going to simply have p is equal to 1 over 3. So this is the other solution for p. But remember what we are looking for. We are looking for the value of x, and at some point we said p should be 3 to the power x. So we are going to do the next part, whereby you are saying taking p is equal to 5. So when we take p is equal to 5, then we need to understand that we had to say p is equal to 3 to the power x. So where there is p, you are going to put 5, and this should be equal to 3 to the power x. So to look for the value of x in such a case, you need to understand that in this case we don't have any other way we can work out this. Instead, we just have to introduce logs on both sides. So we can introduce log, or we can just change log, this expression, to log. So we can change this expression to log. So in this case, x will simply be equal to log 5 base 3. So you just simply change this expression to log, since we have no other way we can work out this expression. In other texts, they will tell you to just simply introduce the logs on both sides. So you can introduce the logs on both sides, and yeah, that's okay, but the answer will simply be that. Okay, then we can move on. We can say taking, we can simply say taking p is equal to the one which we found was 1 over 3. Then, so since we have taken p is equal to 1 over 3, we know that p is equal to 3 to the power x. In such a case where there is p, we are going to put 1 over 3, and then this should be equal to 3 to the power x. So this expression can also be written as 3 to the power -1, because this is just 3 to the power -1, since it is 1 over 3, and this will be equal to 3 to the power x. Since the bases are the same, you can easily work out. So that one and that one. So in this case, x is equal to -1. Okay. So ladies and gentlemen, I'll go back to this one. In other moves or in other ways you can solve this one, some people, the way it is, 5 is equal to 3 to the power x. Some people would love to introduce logs on both sides, so they introduce log, which is in base 10 and should be equal to log, they say log 3 to the power x, and this will give them log, this will give them log 5 base 10 is equal to x log 3. And then when they divide throughout by log 3, so x will simply be equal to log 5 base 10 over log 3. So some people would love to use that approach, but when you use this approach, you need to make sure that you work on it and change this expression to base 3. So you can change this expression to base 3. So when you change it to base 3, it will take you back to that expression. So on changing logs to changing the bases of logs, I think there is a video which I have already shared. So this is very easy and short as compared to this one, because you might end up leaving your answer at that particular point, which is not the simplified way. Yeah, you are right, you can be correct, but the simplest way it is this one. Okay, let me move on and look at the other question. So I have this other question, which is 2 to the power 2x plus 1 is equal to 2 to the power x minus 1. Okay, so let me quickly look at the other one. So the other one is 2 to the power 2x plus 1 is equal to 2 to the power x and then minus 1. Let me just check it once more so that I'm sure. Okay, so that's the question. So this question has the same approach as the previous question, so you approach it the same way I approached the previous question. So you're going to say solution. So when you write solution, you can just rewrite 2 to the power 2x plus 1 and then is equal to 3, then you have 2 to the power x, then minus 1. So here, like we stated in the previous question, this can be rewritten as 2 to the power 2x. Since it is addition, you're just simply multiplying, and then 2 to the power 1 is equal to 3, then you have 2 to the power x, and then minus 1. After you do that, you know this guy can be rewritten as 2 to the power x, and then brackets, then you have 2, then dot 2 to the power 1 is just 2, and this should be equal to 3, then you say 2 to the power x and minus 1. After you do that, you can simply do what we did. We can just simply do the same thing. So we can say let p be equal to 2 to the power 2x. Let p be equal to 2 to the power 2x. So when you do that, you can say then, when we do that, then that simply means that where there is 2 to the power 2x, we're just going to put a p. So this will be p squared dot 2 is equal to 3p minus 1. Then you know 2 times p squared, it is just 2p squared. And then this guy can go to the other side, it's going to be minus 3p, and then this to the other side is going to be plus 1 is equal to 0. Then you can use product, sum, and factor. You can try out product, sum, factor. Yeah, if product, sum, and factor doesn't work, you can use the quadratic formula. So 2 times 1 is simply 2, then negative 3 as your sum, then automatically we have 2 and 1, of which both of them are supposed to be negative. So after you do that, you're going to have 2p squared minus 2p squared minus 2p, then you say minus p, then e plus c 1, which should be equal to what? 0. Then you factorize by grouping. So when you factorize by grouping, this will be 2p outside, then open bracket, this will be p minus 1, and then there you can just simply say negative 1. So you can put negative 1 there, then you say open bracket p minus 1, like that. Then this should be equal to what? This should be equal to 0. So in such a case, you can group these guys. So you're going to have 2p minus 1, 2p minus 1, and then you're also going to have p minus 1, and this should be equal to what? 0. So when you work out that, you're going to have p is equal to half, p is equal to half, and p is also equal to what? P is equal to 1. Okay, so these are the two values of p. So now we can look for the values of x, since we are looking for x and not p. So you can say taking p to be equal to 1 over 2, taking p to be equal to 1 over 2, you're going to discover that we are going to have 1 over 2. 1 over 2 is equal to 2 to the power x. Then this can be changed, so this can be 2 to the power negative 1 is simply equal to 2 to the power x. So 2 to the power x. Remember, same bases, so that one and that one will go. So we are going to have x is simply equal to negative 1. X is simply equal to negative 1. So this is your first answer. Then when you take p to be equal to 1, you're going to have 1 is equal to 2 to the power x. 1 is equal to 2 to the power x. So for us to have a 1, then that means that 2 is to the power 0. Anything to the power 0 is 1. So, and then you can say is equal to 2 to the power x. Then this one and that one can go, the bases can go. So you have x is simply equal to what? X is simply equal to 0. So these are the two values of x which you are supposed to find, whereby we have x is equal to negative 1 and x is equal to 0. So ladies and gentlemen, please make sure that you subscribe to our YouTube channel and make sure that you also register with Excel Academy. So we had 3 questions on this, so I'm going to give you this one as your assignment. So this one will be your assignment. Please make sure that you submit the assignment. Okay, you can submit the assignment by using the lines which I'm going to put in the description. Okay, let's move on and look at other questions, if at all we have more. So we have this question. So this question is coming from binary operation. Is it binary operation? No, binomial expansion. Yeah, this guy is coming from binomial expansion and binomial theorem. Remember, I'm handling questions from different topics, so you should be able to follow up. But there will be some specific videos. Let's say binomial expansion, it will have its own videos. Binary operation, its own videos. Sets, there are already videos there. Functions, videos are already there. So go back to my YouTube channel and go in the playlist for mathematics, and you'll be able to see all such explanation on those said topics. Okay, the second term in the expansion 1 minus that and then 1 plus 3x to the power n is 20. Find the value of n. Okay, so one thing you need to understand that we have 1 minus x, we have 1 minus x, and 1 plus 3x to the power n. So in this case, this is your first part, this is your first part, of which this first part it's already worked on, and this is your second part. This is your second part. So now in this case, the only puzzle to work on first is the second part. Then you are going to multiply the second part to the first part. So if you look at an expansion of something like, let's say 1, let's say we say 1 plus x to the power n, 1 plus x to the power n, then our expression will be 1 plus let's say 1 plus nx, and then it's going to go plus, then we are going to have n, and then we say n minus 1, and then we say over 2 factorial, and then you're going to have x squared. So in such a case, this is a basic formula to use. This is a basic formula to use, like that. Okay, so with this in mind, with this formula in mind, what we can do is just look for the formula for the second term, since they're saying the second term in that particular expansion. Okay, but if you want, you can simply go up to that particular point. So when you go at that particular point, you'll be able to also know the second term, because there is also that other part which will change some few things. So in this case, let's quickly expand this guy. Let's quickly expand that one. So 1 plus 3x, 1 plus 3x to the power n. So this will be since the guy is 1 there, so this will be 1. Then we say plus nx, so you say nx. Remember that x is single, so there it is 3x. So you are going to multiply it with 3x. Then you say plus, you say n, and then there to be n minus 1, and then close brackets, you are going to have 2 factorial, which is just 2, and then there it will be 3x squared, which is like that. Then you say plus dot 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 dot. Though going all this way, it's just that I want to explain the application of this formula. But if you know this concept, you can just simply have that one and that one, because the second term will just be based on these two guys. Okay, so after doing that, you can simply rewrite that expression to be 1 plus, you know, that will be what? That will be 3nx. That will be 3nx. Then you say plus, you know, that squared, it's simply 9. Then you have 9 like that, and then this is n minus 1, and then that one will be x squared over 2. Remember, 2 factorial is simply 2, and there is a video for how to find the factorials. So please make sure that you watch that particular video. So with that in mind, with such findings, we can now multiply the first part with the second part. So the first part is 1 minus x, 1 minus x, and then the second part, which we have already expanded, it is just simply 1 plus 3 nx, 1 plus 3 nx plus 1 plus 3 nx plus 9n, then open bracket n minus 1, and then close bracket, you can say x squared over 2. Then you can put plus dot dot, then you have the brackets there. So after you do that, you can easily say 1 times everything there is everything there, right? But if you look at when you multiply 1 by everything there, 1 is just ending somewhere there. So the best thing you can just say, you can exclude this part, this bigger part, because this bigger part is going up to the third term, and we just want the second term, in this case the second term. So this guy you can exclude it as you multiply. So you can say 1 times 1 is simply 1. Then you say 1 times 3nx, it's going to be plus c 3nx plus 3nx. Then you say plus dot dot dot. Okay, plus dot 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 there. Then you can also multiply this one, this negative x, by that. So it's going to be negative x, and then negative x times 3nx is going to give you negative 3nx squared. Remember, when you multiply that by that, it's going to give you the fourth term. So you can say plus dot dot dot. Okay, so with that in mind, the reason why I've made sure that I've multiplied this one by that one, just for formality, but if I want, I can't include it. Yeah, so in such a case, you can simply say 1 plus 3nx minus x. So this will be 1 plus 3nx, 1 plus 3nx minus x, yeah, minus x. Then you say plus, you can put dot dot dot. The reason why I've also excluded this one, it's not part of the second term. This is the third term, so no need of worrying about it. So with those two expressions which we have found, we can easily get the second term. Remember, this is the second term, right? The first term is this one, so this is the second term. So we're going to say 3nx minus x, 3nx minus x is simply equal to 20x for us to find the value of n. So after we do that, we can factorize x there. So we are going to have 3n minus 1, 3n minus 1, close bracket. Then you can say x is equal to 20x. So with that in mind, you know x and x can go there at that particular point. So this x and that x, they'll go. So this means that we have 3n minus 1, 3n minus 1 is equal to 20, is equal to 20. So when you work out this, you need to discover that 3n will simply be equal to 21, because you have to know that the negative 1 will go to the other side and it's going to be our plus 1. So this will be 21. So after you have 21, you can divide throughout by 3, you can divide throughout by 3. So when you divide throughout by 3, what is your n? When you divide throughout by 3, what is your n? So in this case, our n will just simply be equal to 7. So n is simply equal to what? Is simply equal to 7. So that's how easily you can work out this simple question. So guys, please make sure that you subscribe to our YouTube channel. Make sure that you register with Excel Academy. Okay, so let's move on and look at this particular question. It is also under binomial expansion. It's also under binomial expansion. So guys, please make sure that you subscribe to our YouTube channel, and you can also follow us on Facebook So on YouTube it is Dr. Possibility, and then on Facebook it is just Excel Academy. So please make sure that you are able to follow us on those important channels. Okay, so let's move on and look at finding the term independent of x. So I'm going to write solution there, finding the term independent of x. So in this case, you can just simply use the formula n combination r, n combination r, and then a, and then you're going to say n minus r, and then multiply by b, which is to the power r. So after you do that, this is the formula you're going to use. So you can simply identify what is n, what is r, what is b. So if you look at n in our case is just simply equal to 9, and then a is simply equal to 1 over 3x, and then if you look at b is simply equal to negative 3x squared over 2, and r we don't know r, so r can just be r, since it's the first target that you need to look for, especially when terms independent of x. So after that, you can replace where there is n, you put 9, where there is r, you put r, like that. And then a is simply 1 over 3x to the power, then 9 minus r, remember, where there is n you put 9. Then you say dot, you're going to put negative 3x squared, over 2 to the power r. So after you do that, it's just now the game of relighting expressions. You need to just relight some few expressions. So here you can say 9 over 9 combination r, then there this, because it is 1 over 3x, this can just also be written as 3x to the power negative 1, and then up there you can have 9 minus r, and then you say dot, this other guy can also be rearranged, so this can be 3 over 2 and then to the power r dot, you can simply say x squared to the power r. So this can be separated in that way. So once you separate those guys in that way, you can still rewrite this expression. So this expression can be written as 9 combination r, like that, and then you can multiply that guy by everything there, and then you separate those two. So this one can be 3, and then that one times that one, it's negative 9 plus r, and then you can say dot, you get x again, x will be x, and then it's going to have negative 9 plus r, like that. And then you can simply get this one the way it is, which is negative 3 over 2 and then to the power r, and then you can say x squared to the power r, like that. So with this in mind, you can get the values of r, the expressions that are having x. For us to find the values of r, you just simply get the expressions that are having an x. Why are we getting an expression that is having an x? The reason is very simple. So the term independent of x, is the term where x is to the power 0. So in this case, we are going to get those guys. So we will say x negative 9 plus r, x negative 9 plus r dot x to the power 2r, like that. Then because multiplication is commutative, right? So that one can be taken to that particular point and they swap like that. Then this should be equal to, this should be equal to x to the power 0, x to the power 0. So after you do that, you can make this using the exponent rules, because this guy is multiplication, so you are going to add on top. So it's going to be x, then it will be negative 9 plus r, negative 9 plus r plus 2r. Negative 9 plus r plus 2r is simply equal to x to the power 0. Remember, same bases, they always cancel each other. Same bases, they always cancel each other. So that one and that one will go. So you have negative 9 plus 3r, negative 9 plus 3r, because r plus 2r is just simply equal to 3r. Is equal to what? 0. So when this guy goes to the other side, you're going to have 3r is simply equal to 9. When you divide throughout by 3, it's going to be r is equal to what? 3. So now we have found the value of r. So we can now simply easily, we can just easily replace where there is r, we put a 3. So where there is r, we can just simply put a 3. So I hope you guys have followed, and I hope you guys are able to work on this guy up to this part. Okay, so let me quickly move on. So I'll rewrite the expression, which is 1 over 3x, 1 over 3x minus, you say 3x squared over 3x squared over 2 open bracket to the power 9. So remember, we have already found r. We have already found r to be equal to 3. So this will now be 9 combination 3, 9 combination 3, close bracket. Then there you can say 1 over 3x, then you say to the power 9 minus 3, and then there you can say negative 3x squared over 2 to the power 3. So after you do that, 9 combination 3 can be rewritten. 9 combination 3 can be rewritten in such a way that this can be written as 9 factorial. Okay, this can be written as 9 factorial. Okay, over, then you say 9 minus 3 factorial dot 3 factorial, and then this one, when you work it out, it's going to be something like 1 over 3x, and then on top it will be a 6, and then there it will be negative 3x squared over 2 to the power 3. So once you work out that, because you are not allowed to use a calculator, so this guy you can say 9 times 8, 9 times 8 times 7 times 6 factorial times 6 factorial, then you say over, you know, 9 minus 3, it's just 6 factorial dot 3 factorial. With that in mind, you can now work out that guy. So you have now you now have 1 to the power 6 is simply 1 over, then you can say 3 to the power 6, which is just 3 times 3 times 3 times 3 times 3 times 3, so which is just giving us 729. Okay, so 729 x to the power 6, and then cross bracket we say negative 3 to the power 3 it's going to give us negative 27. So this will be negative 27 and then x to the power 6. Then over 2 to the power 3 is simply 8. Okay. With that being done, so what you can now simply do is to cancel that one and that one because they are the same. Then this and that one, they can cancel. And then you can check, can 27 go into 729? Can 27 go into 729? The answer is yes. It can go there 27 times. So in such a case, this one will be 1 and that one will be what? 27. And then you are going to just say 8 times 27. But let's go back to this other part of So here you can simply say 9 times 8 times 7. Then you say over. Remember, you don't have a calculator. You say 3 times 2 times 1. Okay, and then this will be multiplied by, you say 1 times negative 1, it's simply negative 1 over. Okay, so when you do that, you can simply now say 27 times 8. So what is 27 times 8? The answer is just 216. The answer is 216. Okay, so with that being done, the next thing is for you to also simplify something there. So you know that you're not using a calculator, by the way. So you know that this 2 can go into 8 4 times, and then you know that 3 can go into 9 3 times. So after you do that, you can say 3 times 4 times 7. Okay, 3 times 4 times 7. But you can also simply look at is 216 divisible by 12? Okay, is 216 divisible by 12? Because 3 times 4 is 12. 3 times 4 is 12. So you're going to have times 7 there, times 7 there. Then you're also going to say times. Remember, this don't simply stand for times. Then you say minus 1 over 216. 1 over 216. So can 12 go into 216? Can 12 go into 216? The answer is just yes. So there 1 and there is going to be what? 12 into 216 is just 18. So the answer in this case is just negative 7 over 18. Negative 7 over 18. So this was the answer for that particular question. So guys, please make sure that you subscribe to our YouTube channel and make sure that you also register with Excel Academy. Okay, let me quickly move on and look at that question. So due to time, I'll give this question as your assignment. So in the next video, I'll try to solve these 2 questions. So please, you can solve these questions, and then when you solve these questions, submit them in my inbox on WhatsApp, and I'll be able to guide you where you'll be wrong. Then the other assignment I'll give you is this simple question. Please make sure that you also solve it and you submit. Then the last one, it is this one. So also do the same thing. So guys, for this one, I think I've already solved it. But let me just quickly resolve its solution. So for this one, the first question is find the domain. So you have been given f of x is simply equal to square root negative x plus 4, square root negative x plus 4. So this is simply a radical function. So for you to find the first expression, which is the domain, for you to find the domain, you can just simply say x is a member of real numbers. X is a member of real numbers such that you're going to get negative x plus 4 and say is greater than or equal to 0. The reason we are saying is greater than or equal to 0 is that we don't want any negative value in that particular equation. So with this being done, you can simply say x is a member of real numbers. Then you can take negative 4 to the other side. So it's going to be negative x is greater than or equal to negative 4. And then after you do that, you can simply say x is a member of real numbers. X is a member of real numbers. Then when you multiply throughout by a negative 1, you're going to have x and the sign will change, and this will be less than or equal to 4. So this is how your domain is. Then the next question is sketch the graph indicating the y-intercept. Sketch the graph expressing the y-intercept. So if you look at this graph, it's going to have the y-intercept is where x is 0, right? It's where x is 0. So if you look at that, you can just simply say y is equal to square root negative x plus what? Plus 4. So when you put x 0 there, it's going to be y is equal to square root what? Square root 4. And this will give you a 2. Yeah. So the y-intercept in this case is just a 2. So please make sure that you are able to watch a specific video on how to find the domain and sketching the graph of radical function. It's on one of the videos which we have shared on our YouTube channel. So as usual, when you talk of the Cartesian plane, it's going to have the x-axis and the y-axis, of which if you look at the domain is the one whereby we have f4 is starting from 4 and then it's going toward this side. There is no domain which is this side. They only need values which are less than what? Values which are less than 4. So you pick it up from there and just simply go like that. And then the y-intercept is just a 2. So you can put a 2 there. So this is the value. And then the range is just the y is equal to close brackets 0, infinity. So this is just the range, or you can simply say x is greater than or equal to 0. So this particular part I've indicated here is just about the range. Okay guys, so please go and watch the video on that. Then I have this other question. So determine, giving reasons, whether the following relation is a function. So you write solution. Okay. So if you look at what we have been given, is we have been given two sets. So we have this set and that set. Okay. So for this set, for set A, which actually appeared to be the domain or the input, since it's a relation, so you're going to put it like that, and then the range, which is the output, will be on the other side. So after you do that, you can plug in the values. So the input, it is 0, then the output, it is 1, then 0, 1, 2, 3, all are the inputs or the domain. Then the output, we have A, B, C, D. So we have been asked to represent this, or we have been asked to determine if this is a function or not, if this relation is a function or not. So for us to determine, we need to be able to sketch. Okay, so this is set A. Remember, we have been given the names, and this is set B. So now you can pick from there. 1 is going on B, so you can just simply sketch like that, and then you put an arrow. Then 0 is going on B, 0 is going on B, so it's going like that. Then 2 is going on C, 2 is going on C. Okay, then 3 is going on A, 3 is going on A. So the question is, further find the range of the relationship and then determine if this guy is a function. So this guy is a function. So this guy is a function. Part A of this question, the answer is that it's a function. The relation is a function. Is a function. Okay, is a function. Why? Because all members in the domain have the range. All members in the domain have what? Have an image or have a range. Have an image or have the range. You can use search. You can also put where there is domain, you just put the word input, and then where there is range, you put output. Find the range of the relation. So if you look at the range of the relation, you just pick up these guys which are there. So the range of the relation is just simply A, and then you also have B there, and then you also have C. So these are the range of this particular relation. Remember, D has no input or domain. So for this relation, the range is just this particular guy. Okay. So guys, there is also this type of question: determine whether the function is odd or even. There is a video on our YouTube channel, so please go and watch it and be able to solve this question. So when you solve, please make sure that you send it to my inbox. Thank you very much guys for joining me. This was Dr. Possibility from Excel Academy. Please make sure that you subscribe to our YouTube channel. Make sure that you register with Excel Academy. Thank you very much and have a blessed